So yeah, well, my topic will concern a little bit of React Native and also some parts of the deployment cycle. So I will not dive into specific of React. I will rather make some brief description of how to deploy an application written in React Native. Well, as Jan said, yeah, I'm working in Sermedia. I'm also working in NIDED. So this is the company that does the security, personal verification, document verification. And of course, I also work in Sermedia and project called Cancer Center. So a few words about me. I started as a mobile developer. I did Android, I did some iOS. Then I switched to the web. I did mainly Python work. And with the time, I went towards web development and machine learning. So if you are into it, here is the link. It's ResearchGate for my work, for my papers. And well, I also, as you can suspect, I'm doing some work in React Native. So yeah, let's get serious. So who likes pizza? Okay, yeah, fair. So according to very, very good source, which is pizza.com, 94% of Americans eat pizza regularly, so we can assume that they like it. So I thought that that would be a good idea for a topic. Therefore, well, you know, introducing pizza or not. So if you are into it, it's in the Google Play. It's application, I think it's a daily use application. If you ever wonder if it's pizza or not, you have to make a picture and it will tell you if it's pizza or not. So this application will be like kind of source of what we will go through. It will be based on it. I will have some cases that I had to go through to deploy it to the market. Yeah, so agenda, let's say in this graphical way, would be we have the mobile application and then we want to build it, then we want to run some tests on the built application and then deploy it to the various stores. And of course, as the application is live in production, we need to have some feedback. So we will connect to some sort of reporting systems. And in like more technical way, so here, actually, just a second, let me see. Because I'm supposed to see it here as well, but I don't, so I have to look here. So, okay, as a developer, I want to have automated builds. So by this, I mean we have to bundle the application before it can be deployed, before releasing it to the store, so that I can avoid manual labor. If you are not going to automate it, you have to do it by hand. Then I want to test the application. Of course, all the user stories and flows that were prepared for it. Of course, the next step would be to make this automated deployment. If you ever did deployment for iOS, you know it's a hell. It takes a lot of time, it's a lot of labor, manual labor, where you have to generate the certificates, you have to generate provision profiles. If you want to add the new device, you have to regenerate everything from scratch. So it's super hard and it requires a lot of work at start. And yeah, and the last point would be to have some built-in reporting mechanism so that I will be able to monitor the live performance of my application. So step one would be builds. So the first way to achieve it, I'm not sure if you are familiar with the tool called GitLab. All right, so GitLab is, it's like not so new anymore, but it's a recent project that is winning in terms of self-hosted. So they have like 89% of the market, and they are trying now to win with GitHub. So they are fighting for this cloud-based Git. So well, basically GitLab is a something like GitHub, though it has more features into it, and it's designed to be self-hosted, but you can use GitLab.com, so this is the cloud version of it, and it's free. You have workers for free, you have ability to make CI for free, so it's packed with a lot of features. So first way to do the build would be to use their pipelines, and so GitLab CI is a like YAML file that puts the configuration of this pipeline. And here we first of all we use the image. So, well, you need to have a Docker image. So let's say operating system that will have Android, or if you want to build iOS, that will have iOS or Android packages installed into it. And then it defines stages, so basically what steps it has to go through in order to complete. And here we have the definition of the build stage and what it does. So if you are familiar with deploying React Native, you have to either npm run, npm install, or yarn, and then use GrillJS, which is the Android tool to assembly the release project. And it will go through the Android project and will build the application. And then it has this concept or artifacts. So it means that this directory will be left over. So the data that will be produced in directory will be saved. And in this directory, we'll have the Android APK. So this is the first option. The second option would be to use Bitrise CLI. So Bitrise is a cloud-based builder. They're also like rather new on the market. They offer the building for free, but if you want to have multiple users, or if you want to have more than, I think, 30 builds per month, you have to pay for it. But they recently open sourced their client. So you can download actually the client that they are using on their website for free and use it in your own life cycle. Therefore, you can have the unlimited number of builds on the GitLab. So the second option would be to use GitLab with this client. So here we have Bitrise YAML. So once again, it's a configuration file that describes the steps of the building, and on the left we have an image, because they have a cool web interface that you can design the build steps. They give you, like, in the beginning, all you have to do is to select either iOS or Android, and based on that, they will give you initial pipeline, and you can tune, you can add additional steps, you can look through it. So those steps would be compiled to this file. So as you do this on the web, you can, from the web, you have an option to download this yarn file, and you will be able to copy it to your project. So this file says, first of all, clone the project from the repository, then install missing Android dependencies. So it will figure out on itself, based on your Android requirements, what version of Android tools to use, what version of Android SDK to use, etc. And then, of course, it will install the React dependencies. And the last step is to run Gradle. So it's the same that we did previously, though it's done through the client. And another way would be to use Fastline. Fastline is, well, used to be free and open source. It was a few months ago. It was purchased by Google. It's still open, but the future is unknown. But it's a very powerful tool. It was written as a hackathon project. So what they do is that the idea was to build something that would automate the iOS development. So the guy who did it, he was an iOS developer, and he was really frustrated with the way the way iOS works. Because as I said previously, it's like a lot of manual labor all the time. Each time you want to deploy application, you have to click through Xcode, you have to wait, you have to put your password, you have to generate the profiles, etc. So And also, like if you want to deploy application, you want to take screenshots of the new version, and you want to send those screenshots to Apple Store, and it takes time. The UI is really crappy. So what he did, he wrote application that well, using the website is sending all this data automatically. Later, he integrated with APIs, and now so here you have like example pipeline what you can do with this fast line. So you can take snapshot, you can send the notification to the Slack regarding the deployment status. You can send it to both Android and Apple stores, and a lot of other options. So our initial, so this is one is for iOS. So the previous ones were for Android. For Android, building is much easier. If you would like to make the building for iOS in command line, there is no way. You have to click through, you have to do it manually. So luckily there is a fast line, so if you want to apply the same idea for iOS, you can use the fast line. And what it does here, so first instruction will install pods to the project, then it will produce the application, and it will download the certificate, it will sign the application, and then Gem is the way to assemble it all together. And of course, then we can integrate this configuration file to the same pipeline we had previously, to the GitLab CI configuration file. So this time we are using different image, so different system that will has, it's like, if you check it, it's a Debian with Fastline installed. It's like, that's it. You have to have the basic operating system to run inside of GitLab CI. And here it will, instead of doing manual steps, it will just go Fastline iOS beta. So this is the platform and then the lane, like you can have several of them. And also, you know, publish the results of this folder, which is, yeah, and the last option, the easiest one, and the one that I would recommend, at least for those who are doing it for the first time, is just use the website. So as I said, the initial fee, well, it's free as long as you are not doing too much on it. And I mean, 30 builds per month, it's like you'd have to build every day. And by build, I mean the whole release cycle. So how much you release the application to the stores. So here we have well, this is how it looks like. And on the left, you have some of the available, let's say, workflow elements that they allow. So they have elements like utility, they have notifications, they have deploy, tests, etc. And they're integrated with a lot of cloud solutions. They are able to build for Android, they are able to build for test flight, etc. But they are unable to build to iOS yet. So if you have iOS application, you have to go with the previous version. So, well, we briefly talk about builds. So now we will jump towards the testing. And by testing, I mean automated tests. I'm not talking here of manual tests. We want to make this whole pipeline fully automated so that we will spend as much time on development part and not on the releasing part. So this is the pyramid of testing. Well, probably you are familiar with it. It's like Google is trying to sell it everywhere. And actually they said once that they suggest to split the test into 70-20-10. So we would have 70% of tests, it's supposed to be the bottom of the pyramid, so it's supposed to be unit test, 20% integration test, and some end-to-end tests. And the reason why I will try to talk about it with specifics. So, well, first of all, what's end-to-end test? So end-to-end test is a test that's performed from the point of view of user. So usually it's some kind of black box. So the test doesn't know about the application states. It's not connected. It knows as little as it can. It tries to simulate the user behavior and then explore the application and validate if the parts of it are the way it's supposed to be. So here we have an example. This is the script that it's written in Selenium. Well, it's written in JavaScript, but it uses Selenium. And so what we have here is basically we are waiting for given screen to exist, then we are waiting for the animation to perform, sending some keys, tapping button, waiting some time, and then validating if home page that's supposed to be displayed is shown. So the simplest end-to-end test as you can have. So what are the pros and cons of it? So first of all, the huge advantage of it is that we are testing it from the perspective of user. So if it's working there, we have a high probability that it's working. So we are not checking specifics, we are checking it as a whole. And yeah, as I said, it's the way the end-to-end test interacts with the applications through the either simulator or real device. Therefore, the quality of it is rather high. The issues with with end-to-end tests is that they are relying on the GUI of the application, and those are things that often change. And so each time we change something, the GUI, we have to rewrite the test. Like if the given button will be somewhere lower, we have to scroll to this button, etc. Well, once again, due to the fact that they are interacting with the application the way the user does, they are prone to checking the same functionalities in several levels. So if we have a login screen, each time we open application, we have to go through the login screen to perform given actions. So each time we will check it, therefore it takes long time. And they are not deterministic, because like if you wait half a second, the animation may finish or may not, depending on the phone quality or if phone is doing something in the background. So, well, I was very, when I was talking about, I was kind of highlighting those like pauses. It's super strange that this construct is still used. But unfortunately, this is the cause of the black box, because there is no way to tell if it's something is there or not. We have to wait and then check. So luckily, in React, someone, was worried about it and introduced some gray boxing solutions. So by gray box, what I mean, gray box is a still concept that interacts with the application on the level of the user, so it doesn't know of application states or application elements, but it does interact with the React itself. So it has hooks on the animation level, it has hooks on the networking level, so it does check the interaction with the application based on those. So for example, here we have code that basically look for the email field, check if it's visible. If it's there, then basically put some text into it, put the password, and tap on the button that says login. And then we are checking if the next screen shows welcome. So as you think about it, there is a missing pause here. So we tap on the button, so probably some animation that are switching to another screen occurred, and there is no pause here. There is no wait for. The way it does, it actually have hooks in the animation, React animation, and it knows that React is performing animations, or it knows that the React is still fetching some data, so it will wait until this action is done, and then it will validate next statement. So this is thanks for awaits. This is possible, like you can pause here and wait as long as you have to, and then it will go to another statement. So, they have, this is the whole API. So as I said, you can tell that it's a high level of abstraction. You can't really do much. You can do some scrolling, swiping, so typical user interactions. And also, like expectation that you can have is only if it's there or only if it have given value. So you can't validate, like, let's say, number of items or the state of it. So here is example of how it works. well, what it does on the simulator, it installs the application and then it goes through the test, and well, you can tell it's fast. And it's fast because we are not waiting half a second for no reason. It knows exactly when the animation is done, so it will continue to the next statement. So next level in pyramid was integration tests, and they are very similar to what end-to-end is. The difference is that they are checking on the lower level of abstraction. We now are connected to the application. We have information about the units, and we are still interacting with the application on the level of the user, but we have some additional insights. So here we can tell, for example, I am able to find given elements by the ID of this element, and I am able to perform some methods of this object. So, and still I'm able to do the same as check if the object exists, which is obvious. So KV is, well, I guess the one and only currently for the integration tests, and well, the API is similar to the detox. But well, it requires more action, because in order to have access to given elements, you have to simulate them, so make some shallow rendering, you have to hook the scene, etc. So there is more work to do in order to receive it. Therefore, like, you have to write often components, once for testing and another for production. Therefore, it's kind of not so useful anymore. And well, this is how it works. It works on the same level as detox, so it runs the test inside of the simulator. And of course, unit tests, the lowest level you can have. So of course, we are testing given functions. It's super fast. It's reliable. It's not prone to failures like the previous ones. And in addition, if it fails, we exactly know what failed. We know the given logic that is not working. In case of end-to-end test, we just know that something, given action, failed. We don't know what happened. We have to still figure it out. Here we know the exact point where it failed. Yeah, and here it doesn't test user interactions. It just check if given components, if this logic is fine or not. So yeah, that would be part about the test, and now we'll go to the deployment. So deployment, we can deploy to several points. We can deploy to App Store, we can deploy to Google Play. They both have some kind of internal tests. And there's like alternatives such as Hockey App and others, where you can push both iOS and Android application and then deliver them for the users. So once again, we will go with this step-by-step points. So first version would be to use GitLab C and make those scripts manually, but it's too complicated, so I skip this part. It's both Android and iOS stores, they have open API, but no one really does it the way that you will send curl request, or it's complicated, so we can skip it. The obvious way would be to use Fastline. It was designed to push applications, send data, send screens. So once again, we have Fastline. This time the lane is called deploy. So this is the one for iOS. So we are downloading the certificate, applying the certificate, signing the application, and then using deliver. Deliver is a wrapper that works both for Android and iOS, and it will basically connect to Apple Store and use this build package to send it. And the way for Android is similar. We don't have to download certificates because they don't have certificates. And then the pipeline that we would run on GitLab CI would basically invoke those two. So deploy for iOS and deploy with Android, and it will do itself. Alternative would be to use Btrace again, the CLI. So here what we have to do, once again, install dependencies, build the application, and then use the Google Play deploy. We have to set some information like a package name and service account. So this is the JSON file that you can download from the Google page. But the problem with it is just Android for now. So if you want to deploy for iOS, for the store, you can't do that yet. And well, the easiest way, once again, is to just use the website. So this is an example, like if you select the Android, it will tell you exactly, okay, you need a key store, there is a link how to generate it, just drop it there. Well, if you want additional files there, you can just drag and drop. And you have multiple sources that you can deploy to, so TestFairly, Google Play, as I said, Hockey App, etc. There's a lot, and they are integrated with a lot of testing frameworks. So yeah, that would be about the deployment. So the last part is about error reporting. So the reason why it's important is that React works on a different level than native code does. You know, like all of it is in the single core. There's a bridge that communicates with the native code, and when we have a failure in the application, it's often the failure comes often from the native level, not from the JavaScript level. And in the JavaScript, we have no access to it. We can't follow it. We can't find the source of it. Therefore, we need some kind of reporting, but on the level on the native layer that's also aware of the JavaScript layer. So we need a solution that's able to track both native code and track JavaScript code as well. And well, there is a package called React Native Sentry. Sentry, once again, it's self-hosted. It's an open source project. You can, well, deploy it on your own, or you can use the cloud solution. It's free to a given level of users. And, well, if it's fine for you, you have it for free. If not, you have to pay for it. So the important part about this project is, as I said, it works with JavaScript and it works with the native code. So it will track the errors on both levels. You have an option to connect it to the issue tracker like Jira, Redmine, or whatever you use. They have it. And yeah, well, of course, in order to map the errors, because as you bundle the application, your code is gone. It's now the bundled version of your code. So in order to track the errors in your original code, you need some kind of source map, which is obvious. And well, in order to have it, you have to give them the source map. So each time you release new version, you have to somehow send them the source map that will give the linkage between the compiled code to the original code. So this is how the example error would look like. So we have the information about the user, we have information about the environment type, about the link of the application, and also thanks to the fact that it has a source code and it has a source mapper, it's able to showcase, okay, this line caused error, well, this line is throwing an error, so it's kind of obvious. And yeah, it all, instead of using like native throws, you can also, they have also API that can expose the messages for the developer to interact with. So for example, you can capture messages, so send any kind of JSON object to the server and track it down, or capture the exception. So if you have a standard JavaScript exception that you don't want to throw away, so you don't want to throw the exception to the user, you just want to catch it, you can do it this way. So configuration, so we had it before. So this is the fast line for iOS. So we had those steps previously, and now what we have to add is luckily, well, Fastlane is built by community, or at least before Google acquired it, it used to be. So you have plugins for most of the open source projects, and there is a plugin for Sentry as well. So what it does is, after the build is done, it will also fetch for your testing file, and it will create the new release. So it will tag it with the version. So then if the error occurs, it will know the version, and it will be able to use the link file and your source code to show it on the web. So with it, we completed the whole pipeline. And either if it's GitLab, so on the left we have this whole pipeline that's executed on GitLab. So we have a build, we have the test, and we have a deploy, or whether it's a pipeline that's executed on bitrise.io, it will result in the same. So it will let you to execute all of those steps that you normally do yourself in the automated way. And cool fact about Fastlane, when it's done, it shows you the time that it consumed to perform those steps, and it computes the time that it would take to do it. So in the larger builds, you save about 35 minutes each time you deploy the application, which is huge. And this whole pipeline, it takes 8 minutes. So you can tell it's worth it, especially if you are working with multiple applications or you release often. It saves your time, and it lets you spend more time on the development. So that would conclude my topic. So if you have any questions, feel free.
So about end-to-end testing on the continuous integration system, do you know about any tool which performs the gray box testing like Detox does for Android? Because it now works only on iOS,
yeah, well, right? So there's a version of Detox for Android. It's like a still branch. They are having some issues with the Android permissions, and that's why it's not released yet. But it's working. You can use it, but you have to be aware that if you are using, let's say, camera, there is still no way to allow this application, because on the Android you have this pop-up that will ask you, can I use this camera? You have to click allow, and they haven't figured out the way how to pass by it. So as long as it's a simple application, you can use Detox currently.
Any other question? Okay, so thank you, Piotr, for your great speech.